Now, we will calculate H parameters for some example circuits. As usual, we will take the same circuits as we did for the other two parameters, so that you can compare the results. Okay. This is the circuit for which I would like to compute the H parameters, port 1, port 2, and I need two cases. One in which port 2 is short circuited and you apply a current to port 1, and the second case where port 1 is open circuited and you apply a voltage to port 2. Okay. Now, this is kind of getting repetitive. So, those of you who are very familiar with circuit analysis, I suggest that you simply calculate the H parameters of this and forward to the end of the lecture and see if they match whatever I derive. If you are not very comfortable with circuit analysis and these parameter definitions and so on, so you can follow the lecture. Again, I would still encourage you to do the calculations first, but you can follow the lecture completely. Okay. So, now what I need to evaluate in this are I 2 in this direction and V 1, the same for both circuits I 2 and V 1. So, let us take the first circuit over here. This short circuit across port 2 is shorting out this 1 kilo ohm resistor. So, no current flows through this 1 kilo ohm, and all of I 1 flows in that direction, okay, flows that way. So, this V 1 is nothing but the voltage drop across this 1 kilo ohm resistor, okay, which is 1 kilo ohm times I 1. So, after that we have a short circuit. So, V 1 is 1 kilo ohm times I 1, and I 2 you can see that it is simply the opposite of this current I 1. So, I 2 is minus I 1, and from these two what do we get? H 11 is V 1 by I 1 with V 2 set to 0, which comes out to be 1 kilo ohms, and H 21 which is I 2 by I 1 with V 2 set to 0, and this comes out to be minus 1. Okay. So, you can see that H 11 has dimensions of resistance and H 21 is dimensionless. Okay. It is the current gain from port 1 to port 2. Now, coming to the second case over here. So, here this 1 kilo ohm is in series with an open circuit. So, no current flows through that. All of this I 2 is simply the current through this 1 kilo ohm, okay, and V 2 appears across the 1 kilo ohm resistor. So, the current here is nothing but V 2 divided by 1 kilo ohm, okay, and V 1 equals V 2 because no current is flowing through this 1 kilo ohm resistor. So, we have V 1 to be equal to V 2 and I 2 to be equal to V 2 divided by 1 kilo ohm or 1 millisiemens times V 2. From these two you clearly see that H 12 is 1, that comes from this equation, and H 22 is 1 millisiemens, that comes from this equation. Okay. So, the H parameter matrix for this circuit as expected has hybrid quantities. The resistance here is 1 kilo ohms and this is just 1, this is minus 1, and there we have 1 millisiemens. Okay. So, that is the H parameter matrix of this circuit. So, again taking a more complicated example with a control source, we can also calculate the H parameters 1 kilo ohm, 1 kilo ohm and 2 millisiemens times Vx, where Vx is over here. And for the first case, we set V2 equal to 0 or short circuit port 2, apply current I1 and we want to find this voltage V1 and that current I2. Okay. So, how do we do this? First of all, this I1 simply flows through this 1 kilo ohm. So, across this we have I1 times 1 kilo ohm. Okay. Now, you see that there is a short circuit from here to there. So, the voltage V1 is simply the voltage across this 1 kilo ohm resistor. So, V1 is 1 kilo ohm times I1 or H11, which is V1 by I1 with port 2 shorted is 1 kilo ohm. Now, because of this short circuit, no current flows through this 1 kilo ohm resistor. Whatever I1 was there, okay. So, this I1 flows into this 1 kilo ohm and through the short circuit. Okay. So, I1 flows that way, but that is not the only current that flows there, okay, because we have the control source as well. And how much is the control source? It is 2 millisiemens times Vx, and Vx is nothing but V1 and V1 is 1 kilo ohm times I1. So, this current over here which flows in this direction also through the short circuit, because there is a short circuit across the control current source and all of its current will flow through the short circuit, will be, remember it is in opposite direction to I1 and that is 2 millisiemens times Vx, which is V1, which is 1 kilo ohm times I1, which is 2 I1. Okay. So, we have I1 flowing directly this way and 2 I1 flowing there. Okay. So, the actual current that is flowing in this short circuit, okay, the total current, I just showed this I1 over there, it is not the current flowing here. The actual current flowing there is the sum of I1 which is coming from there and 2 I1 which is going there, which is equal to I1 flowing that way. So, I2 will be exactly equal to I1 in this particular case. If this control source has a different proportionality constant, it would be different. So, we have I2 equals I1, which tells you that H21 is nothing but 1. Okay. So, that is the value of H21, the current gain from port 1 to port 2. Now, for the second case, we have port 1 open circuited and a voltage V2 applied to port 2, where Vx appears there. Okay. So, again we have to calculate this current I2 and this voltage V1, and you see that Vx is the same as V1. Okay. And also no current flows through this 1 kilo ohm resistor. So, the voltage V2 here is exactly the same as V1. Okay. So, we have V1 equals V2, which tells you that H12, which is V1 by V2 with port 1 open circuited, is simply 1. Okay. So, now we have to calculate I 2. First of all, this V 2 appears across the 1 kilo ohm resistor. So, we have V 2 by 1 kilo ohm or 1 millisiemens times V 2 flowing through the resistor. And we also have 2 millisiemens times V x, which is 2 millisiemens times V 1. V 1 is the same as V x, which is also the same as V 2. So, the current here is 2 millisiemens times V 2. So, the total current I 2 is 3 millisiemens times V 2. So, I 2 is 3 millisiemens times V 2. So, H 22 is I 2 by V 2 with port 1 open circuited, which is 3 millisiemens, and the H parameter matrix of this is H 11, which is 1 kilo ohm, H 12, which is 1, H 21, which is also 1, and H 22, which is 3 millisiemens. Okay. So, that is the H parameter matrix. Okay. So, again you should be able to calculate this easily. Calculating of the 2 port parameters is simply regular circuit analysis. Okay.